Good morning, friends. In this video, we are going to discuss about very precision angular measuring instrument called SINE bar. It works on the principle of sine, that is, uses the ratio of two sides of right angle triangle in deriving a given angle. That is, sine angle equal to opposite side by hypotenuse. This is a basic principle behind the working of SINE bar. SINE bar, it is a hardened precision ground body made up of high carbon, high chromium, corrosion resistant steel. The body is mounted on two precision ground cylinders of equal diameters fixed at its ends. The distance between these two cylinders is precisely known and controlled. The axes of two cylinders are parallel to each other and parallel to the upper surface. The distance between the two cylinders is around 100 millimeter or 200 millimeter or 300 millimeter. This distance, this length is the hypotenuse of a right angle triangle. Holes are drilled in the body of the SINE bar to reduce the weight and also to facilitate the handling of the SINE bar. The distance between the two rollers, as I said, it is 100, 200 or 300 millimeter. That will be the hypotenuse for right angle triangle. These two axes, the cylinder axes, are parallel to each other and parallel to the upper surface. This, if you come to know this, the datum line, one roller is kept at a height of h with the help of slip gauges. Slip gauges is available at various thickness. According to our need, we can arrange the slip gauge and that height can be taken. So sin theta is equal to opposite side by hypotenuse. Hypotenuse is nothing but the distance between two rollers. Height is slip gauge height. With this, we can measure the angle of any component. So these are the various measurements we can have, but the angle of measurement is limited to 45 degree. Considering the stability appreciably decreases with the steep angles. The stability of SINE bar, if you go beyond 45 degree, the setup or stability of the SINE bar decreases. That's why we are not going beyond 45 degree angular measurements. By building slip gauges to height, as I have told earlier, and placing the SINE bar on a surface plate with one roller on the top of the slip gauges, the upper surface can be set to a desired angle with respect to the surface plate. So this is a measurement. We have to ensure that the angle, what angle we are going to measure. Here we have arranged the slip gauges. Always we will place the SINE bar or any instrument, measuring instrument, over the surface plate. The surface plate is the flat made up of cast steel, or sometimes it is made up of granite also. The upper surface is of having flatness. It will be checked using flatness measuring instrument like auto calorimeter. Over that only we are going to place the dial indicator, SINE bar, slip gauge, everything will be placed over the surface plate. The work part is kept over the SINE bar, and that angle we want to measure, the angle of the work plate we want to measure, this angle we want to measure. But the upper surface is kept parallel. We have to see to that the dial indicator shows the common reading, constant reading throughout this movement of the upper surface of the work part. After ensuring that, we have to count the slip gauge height, and already we know the depth, distance between the two rollers, that will be nothing but hypotenuse. This is height, so we can easily measure the angle of the work part. This is the principle of measuring angle using the SINE bar and slip gauges. We are using the dial indicator to ensure that the upper surface of the workpiece is parallel to the surface plate. Yes, this angle we are measuring. This is a pictorial view how we are keeping the sidebar over the granite surface plate. This is a sidebar with different holes to reduce the weight and to handle it. We can make in different shapes according to our need. Normally it is of rectangular block in this shape. This is a part we have seen earlier. Over the surface plate of the component is placed. Over the component, sidebar is kept. Here we have the vernier height gauge, and here we have stylus for uh, accurate measurement. And this is a sidebar. It is used for accurate and precise angular measurement. It is cheap and available and easy to handle also. It is difficult to handle the position, the slip gauges if the angle exceeds 45 degrees. So sidebar is impracticable and inaccurate if the angle goes beyond 45 degree. Error in distance between the rollers. Error in slip gauges combination used for angle setting, that is if there is any air gap between the slip gauges, if we are not doing proper wrangling, that also lead to some error. The arrangement of slip gauges, qualitative size of rollers and cylinders accuracy in the form of rollers, error in parallelism of roller axes with each other, error in flatness of the upper surface of the bar. That's why they are saying that we have to maintain the sidebar in a precise way. We have to apply the oil or grease and we have to make the upper surface very smooth. We have to clean it and we have to ensure that upper surface does not have any corrosion or erosion or any dust particles, any scratches. We have to ensure. Otherwise, the reading what we are going to take will not be of accurate. It will have some errors. So that we have to ensure that it is properly maintained. In similar way, the slip gauge, ringing of slip gauge also to be done in a perfect way. We have to ensure that there's no air gap, there's no scratches, there's no dust particles over the slip gauges. We have to clean periodically and we have to apply the grease and we have to maintain it in proper way to ensure there's no corrosion and erosion. So we can measure the unknown angles. The actual angle is calculated using the total height of the slip gauges, as I already have told. This is one type of slip gauge to align the centers. Alignment of centers can be done. Side center. This is called the side center. This is a conical workpiece. This is a conical workpiece. This is a sine bar. This is a slip gauge height. We are clamping over the sine bar. We are measuring the conical angle of this workpiece using the dial gauge. And as usual, we have to measure the height and we have to measure the distance between the rollers using the formula sine theta equal to opposite side by hypotenuse, length by h. We can measure the angle of the conical workpiece. We have to ensure that the upper part of the conical is parallel to the surface, upper surface of sine bar. That's the only point we have to consider here. We have to clamp these two centers using the clamp. To hold the workpiece, we are using these two centers. This is a dial gauge to ensure that it shows constant reading throughout the movement of the upper surface of conical workpiece. Using the sin theta equal to L by H, we can measure the angle of this conical portion. This, like this, we have to do this. This is the dial gauge. This is a clamp. We are moving this dial indicator over the conical shape. These are various setups available in this surface plate. We are keeping the sine bar and we are measuring using the conical angle of the conical workpiece using the sine bar. The SINE center, this is called SINE center, which provides convenient means of measuring angles of conical workpieces that are held between centers. That's why it is called SINE center. One of the rollers is pivoted about its axis, thereby allowing the SINE bar to be set at an angle by lifting the other roller. The base of the SINE center is a high degree of flatness, and slip gauges are run and placed onto it set the SINE bar at the required angle. Conical workpieces that need to be inspected are placed between the centers. The SINE center is used for measuring angles up to 60 degree. Whereas SINE bar is used to measure the angle up to 45, whereas SINE center is used to measure up to an angle of 60 degree. The procedure remains the same as we have in SINE bar. Dial gauge is used to set the against conical workpiece. So thank you for watching this video. We will conclude the SINE bar and the SINE center. Thank you all.